Okay, so this is where we left off yesterday. This is the assignment I asked you all to do last night. Just by having done it, I'll give you a participation point for that rather than submit it. I want you to check your works to make sure that you've done it. But before we do, I want everyone to hold up their worksheet. Hold it up. Okay. Carson, let's see yours. All right. So let's start in the back with Francis. I want you to tell me what would the formula be for tetraphosphorus hexoxide?
P4 O6.
That is correct. Tetra means 4. There's 4 phosphoruses and there's 6 hexoxides. Notice it didn't go hexoxide, it just did hexoxide because sometimes you avoid having 2 vowels next to each other. Sometimes you do, sometimes you don't. All right, let's go to John, Dennis, sulfur difluoride.
Capital S.
You don't need to say capital, it's just,
F.
that's correct. Emma, selenium trioxide.
SeO3.
Okay, Nick, silicone tetrafluoride.
SiF4.
Colby, phosphorus trichloride.
PCl3.
And then nitrogen monoxide. Kendall. NO, nitrogen monoxide. Good. Any questions with writing the formulas? Okay. The last one you haven't done yet, it's called a hydrate. Calcium hydroxide is CaOH2. Then the 5 H2Os. Penta means 5. Hydrate means water. You'll learn that later. Number 8. Max, what is the name for Ni3?
Nitrogen triiodide.
Yep. This is the case where you do have 2 vowels. Triiodide. If you guys put 2 vowels next to each other and you weren't sure whether to do or not, I'm not going to mark you off on it. PCl3. Let's go to Cheeseman. What is the name?
Phosphorus trichloride.
Derek, what is N2O4?
Dinitrogen tetroxide.
Yep. If you put tetroxide, like Tetro, that's fine. I'm not going to mark you off on that. How about SO3, Scout?
Sulfur trioxide.
How about SO2, Alyssa?
Sulfur dioxide.
How about H2O, David?
Dihydrogen monoxide.
Now, do you want to say monooxide or monoxide?
Monoxide.
The only time you really have 2 vowels of the same one next to each other is triiodide. Everything else, you don't have 2 of the same. Now, let me give you guys a little story. A couple years ago, I gave this worksheet, and I was looking at the answers, and I had a kid write this. I'm like, why did you write that? So that's what it is. So did you Google that? Yeah. Because that's not what you're supposed to do. Do you see any prefixes representing numbers on that? No. What that person did is that they went online and they just put in H2O2 and it gave them hydrogen peroxide. That stuff in the brown bottle that's in your bathroom sink or under the sink. That's not what you're supposed to write. So if you did that, shame. What is the true name of it, Juliana? That's better. How about SiCl4? Tim, not here. Nicole? Okay, 5 more. Kevin, N2O.
Dinitrogen monoxide.
Okay, number 17. Adam, not here. Carson Dye, CF4.
Carbon tetrafluoride.
Jade, what is SF6?
Sulfur hydrofluoride.
Cl2O7, Max.
Dichloride.
Do you put "ide" on the first word?
Dichloride.
Correct.
Pentaoxide.
Penta is 5. That's 7.
Oh.
What is 7? Hepta.
Hepta.
And then last one, Colby, Se2P4.
This diselenium tetrafluoride.
Mm-hmm. Are there any questions with any of this, Nicole?
So with the ionic compounds, it mattered which came first, like which element came first, because it was like the positive and negative. But does that matter at all for covalent?
It's going to matter less, but typically you have the one that's, more often than not, you have the one that's fewer in quantity come first. Yes?
Number 19, could you put heptoxide instead of heptaoxide?
Yeah, I'm not going to mark you off for that. All right. Now, I want to get to what she was getting at here. This is something new. This would be kind of on your notes. This is naming compounds, ionic compounds versus molecules. Okay, what you guys just did is you named molecules. There is a difference in naming them. Here's what they both have in common. Second name ends with IDE. Second name ends with IDE. That's really all they have in common. Is you always end the second word with "ide," chloride, fluoride, iodide, bromide, sulfide, phosphide, selenide, nitride, oxide. Here's how they're different. No prefixes when you're doing ionic compounds. You don't use prefixes at all, ever. When you do molecules, you only use a prefix on first name if what? Under what conditions would you use a prefix on the first name? Yeah, if there is more than one. What's the rule for prefixes on the second name? Evan? You always use a prefix. And as you guys saw in yesterday's class, there were a few that had there was no prefix on it. You go to one as a default. So if you saw something like hydrogen chloride, well, hydrogen, there's no prefix, that's one. And if you were given chloride instead of monochloride, just put one. Now, how are you supposed to know the difference? Let's switch over to your notes. Yeah, switch this over. All right, so ionic compounds, just continuing what you already have written down. Here's how you know the difference, guys. You have a cation and an anion. Oftentimes, the cation is a metal, not always, but most of the time, and the anion is a nonmetal. In a molecule, it's two or more nonmetals. There are no ions. Okay, so I'm going to give you a few practice ones, and we're going to move on to continuing to name acids. I want you to take a look at this. NaCl. I'm going to ask you to name that. Now you have to ask yourself, is this ionic, which means it's held together by an ionic bond, or is this held together by a covalent bond, which means that it's a molecule? So you need to look at the elements that compose it. Take a look at sodium. Is sodium a metal or a non-metal? It's a metal. It's found in group 1. It's an alkali metal. Which means chlorine is what? A non-metal. So, is this compound ionic or molecular? I heard both. It is ionic. So, do you use prefixes on this? You do not. So, what would the name of this be? That's it, sodium chloride. Okay, let's try this one. We have calcium on one side. What is OH? Hydroxide. Are these ions? Or are there metals and nonmetals involved? Or are there ions involved? Or are they all nonmetals? Nicole? These are made of ions, therefore it's an ionic compound. Calcium is a metal. It is going to be a positively charged side. Hydroxide is a polyatomic ion. It is going to be the negative side. So is this held together by a covalent bond or is this held together by an ionic bond? It's ionic. So do we use prefixes with this? You do not. So what would the name of this be? You just say the two names and that's it, calcium hydroxide. Okay, let's do like 3 more. How about this? CO4. What is carbon? Metal or non-metal? Non-metal. What is oxygen? A metal or a non-metal? Non-metal. So is this ionic or is this molecular? This is molecular. 2 non-metals. So do we use prefixes? Yes. What would the name of this be? Carbon tetroxide or tetraoxide. All right. How about this? Ooh, that's a tough one. NH4NO3. What do you see? Francis? All right, what are the ions then? Very good. What is that called? Very good. This is a polyatomic ion. And it's going to be your positive one. The positive always comes first. And what is the other one? Go ahead. Very good. It is a polyatomic ion. And it is the negative one. So is this ionic or is this molecular? It is ionic. Do we use prefixes? We do not. So what would the name of this be? Ammonium nitrate. Let's do 2 more. Yes, Kevin.
Why did you say, like, for ionic compounds that the second element always ends in bi?
Well, that's okay. That's when you are not dealing with a polyatomic ion. That's when you're only doing monatomic ions, like the ones that are in just one atom. A polyatomic atom doesn't have the name change. Only the monatomic ones, like chlorine becomes chloride, fluorine becomes fluoride. Those are called monatomic ions. But when they're polyatomic, like phosphate, nitrate, you don't change the name at all.
I mean, you still like sodium chloride.
Sodium, well, because sodium chloride, that's just one element. That's one atom. That's chlorine.
There's also sodium.
What's that?
There's also sodium.
But the second word you change. You never change the first one. You never change the anything on the first one as far as the ending is concerned. It's always been that way. So if I have something like this one, calcium hydroxide, notice how we didn't change the end. You don't change the ending of the first word at all, whether you're doing ionic compounds or molecular compounds. If you look at, sodium chloride, calcium chloride, carbon tetroxide, even on your homework that we just did. Wrong one. Do you see any of the endings of the first words changed? No. It's only the ending of the second word. But when you're doing ionic compounds, the only exception would be if you're doing polyatomic. So to go back to a few weeks ago, when you have a monatomic ion, monatomic, what does mono mean? One. That would be things like hydrogen, chloride, fluoride, oxide, nitride, aluminum ion. Those are just individual atoms. But then you have polyatomic ions. Those are things like ammonia, NH4, positive 1 charge, phosphates, PO4, negative 3 charge, nitrates, NO3, negative 1 charge, carbonates, CO3, negative 2 charge. You don't change the names of those. You only change the names of the monatomic ions. So if I had something like NaCl, that would not be called sodium chlorine. That would be called sodium chloride. But if I had NaNO3, that would be sodium nitrate. You keep it, you don't change the name of the polyatomic ion. You still look confused. You sure? You're not just telling me what I want to hear. Okay. Does anyone else have a question with that? Yes, Juliana.
For OH, when would you use hydroxyl rather than hydroxide?
You can change it however you like. Dealer's choice, I'm going to tell you. Hydroxyl and hydroxide are the same thing. Now, this is pretty important here. I want you guys, based on Kevin's question, I want you to look at these two. Oops. What would the name of NaNO3 be? This is from a few weeks ago before break. Sodium nitrate. Here's my next question. What is the ratio of sodium to nitrates? 1 to 1. Why?
It's one, like nitrate is 1.1.
What is the charge of a sodium ion? Positive 1. What is the charge of a nitrate ion? Negative 1. Let's scoot over here. What would the name of this compound be? You wouldn't. I heard someone starting to say tri. Is this ionic or is this molecular? It's ionic. How do you know it's ionic? These are questions that you will be asked. How do you know that it is ionic? Kevin? It's a metal and a non-metal. Therefore, will you be using prefixes? No. So what is the name of this compound? Sodium nitrite is correct. You see how if I asked you, what if I just gave you the names? Guys, look, sodium nitrate versus sodium nitride. You would have to be sure that you're writing the right stuff. There is a difference here. So sodium nitride, what was nitride before it got the IDE? It was nitrogen, okay? Now, my next question is, what is the ratio of sodiums to nitrites here? 3 to 1. Why? That's right. Sodium has a negative or positive 1 charge. Nitrogen is in group 15. It has a negative 3 charge. We'll probably do some more naming practice in the very near future. Just be sure you guys got this. Kevin?
Why isn't nitrate a molecule versus two non-metals?
Well, this goes back to a few weeks ago. This is a polyatomic ion. They all behave together as one. It is NO3 with a negative 1 charge. This is all one unit. Together, they form a compound, but with a charge on it. And so it's called a polyatomic ion. There's it's on that big list I gave you. There's a very specific group of elements where together they complete each other, but in completing each other as a side, they are going to be charged. Go ahead.
So if there's no charge, would it be?
It would just be a neutral compound or a neutral molecule. So NO3 with a -1 charge is nitrate. NO3 neutral is nitrogen trioxide. Yes.
So if NO3 is together in within like a different like within another with a formula that has another element in it, is that always polyatomic ion, or could that just be like a compound? I know it's not a molecule with nitrogen and oxygen and
It depends on if there's a charge.
like it doesn't show the charge in the formula.
It would have to show the charge. If it's not charged, then it's going to be either a molecule or a compound. If there is a charge, then the whole thing is an ion.
How does it have a charge though if a nitrogen and 3 oxygen?
It's just those unique exceptions. It's never a black and white rule where it's all or none. There's always some exceptions. Okay. I can tell by looking at your faces that we need some more practice with naming, and that's fine. But we're going to get into acids right now. I'll get some more work for you guys to practice with. But I want you to get out your notes where we left off yesterday with naming binary acids. I'm going to pause the video for a second. All right. Yesterday, I was teaching you how to name binary acids. Bi means two, and if it is an acid, there's two things that you must consider. One of the two elements is going to always be hydrogen, always. The other is going to be an atom or a polyatomic ion that does not contain oxygen. So what if I gave you HCl and it was in an aqueous solution? There's a 4-step process here. The first one, if it is a binary acid, it always begins with the prefix hydro, always. The next step is you use the root of the second element. So we're using chlorine here. The root of that is chlor. The third step is you make the ending of the second word ic, I-C. So instead of chlorine, it's going to be chloric. And then the final step is you just make the second word acid. So hydrochloric acid. And then you guys did these last three: hydrobromic acid, hydrofluoric acid, and hydroiodic acid. So let's do a few more examples with this. And then we'll move on to oxyacids. First off, how about if I had hydrogen and sulfur? I want you guys to tell me my periodic table fell down, so you have to look at the one at your own table that you all have either on your desk or in your own possession. I want you to give me the actual formula for hydrogen and sulfur together so that they cancel out. You need to look at the location of them in the periodic table. Raise your hand when you got it. Nicole? It would be H2S. Why did you choose that ratio? So I really struggle at chemistry. I just feel like I don't get it. I have no idea what the heck you're saying. How did you know that hydrogen has one valence or has a positive one charge? It's in the first group. Okay, so she said that hydrogen has a positive one charge. That is correct. I suck at chemistry. I have no idea what you're saying. How do you know that sulfur had a -2 charge? It's in the 16th group, just below oxygen. And so you need two hydrogens to cancel out that sulfur. +1 plus +1 plus -2 equals 0. So you need two hydrogens to cancel out that sulfur. So let's get into naming this. Do you guys see oxygen in this? That's going to be a big point. Do you see oxygen in that? No. So here's the rule. Because there is no oxygen, you will use binary acid naming rules. So, what is the first thing that we do when we name a binary acid? Hydro. Okay, that's the first rule. What is the first step? What is the second step? Kevin? You use the root of the second element. So what is the root of sulfur? Okay. Now I know why you would say that. Sulfur is going to be one of those weird ones. I know I'm making your life not too much easier, but instead of saying sulf, you will use the whole word. There's only two elements that really have this exception, sulfur and phosphorus. And what is the third step? What do you end the word with? Ick. And what is the fourth step? Acid. Hydrosulfuric acid, H2S. Let's try another one.
Can you tell us if it's an acid?
Well, okay. How about this? That's how you should know. It's in an aqueous solution.
Okay.
How about hydrogen and nitrogen? What will the formula be? Look at your periodic tables. Someone besides Nicole. Francis? Why did you choose that ratio?
Because it's
Positive 1 and negative 3. I suck at chemistry. I have no idea what you're saying. How do you know that hydrogen is a positive 1 charge? It's in the first group. I suck at chem. How did you know that nitrogen has a negative 3 charge? It's in the 15th group. You have to know those. So, first rule, hydro. What is the root of nitrogen? Nitro or nitric. And what is the third step? Ick. And what is the fourth step? Acid. Hydronitric acid. All right. Let me think if I can come up. Oh, last one. All right, here we go. Hydrogen and phosphorus. What would the formula be? No Nicole, no Francis, no Kevin. What would the formula be for hydrogen and phosphorus? Derek?
H3P,
Why did you choose a 3-to-1 ratio?
because phosphorus is in the same group as nitrogen, and so it has 3 negative.
Okay. Hydrogen is found in group 1. It has a positive 1 charge. Phosphorus is found in group 15. It has a negative 3 charge. You need 3 hydrogens to balance it out. If Jade weighed 300 pounds and Max weighed 100 pounds, how many of each of them do I need to balance each other out? I need 3 Maxes. I need 1 Jade. 300 to 300. So, what is the first step in naming? First off, do you see oxygen in this? You do not. So you're going to go by binary acid naming rules. What is step 1? Hydro. What is step 2? Get the root of the second element. What is the root of phosphorus? Phosphor. What is the third step? Ick. What is the final step? There it is. Hydrophosphoric acid. Yes, Carson.
So how come you aren't writing it like we usually do, like where you do like the try and like
Because these are acids. When you name acids, some molecules are placed in water and therefore considered aqueous. If a molecule is followed by aqueous, it must be an acid. And all acids begin with hydrogen. So the example we did yesterday was the difference between HCl gas and HCl aqueous. If you had HCl aqueous, that would be, HCl gas, that would be hydrogen chloride. Hydrogen is I know it is a nonmetal, but is it a positively charged nonmetal or a negatively charged nonmetal? It's positive, so you have to go by the ionic bonding naming rules. You're not going to use prefixes with that because hydrogen is a positively charged ion. Yes, Nicole?
How would you know if you see like any of the fluids, and how would you know if that's ionic or not?
How do you know what is ionic?
Like if you see the formula like H3, how do you know that's ionic or not?
Because it should be followed up, either you'll be told name the acid or it'll be followed up with gas, G for gas, S for solid, L for liquid, or AQ for aqueous. If it's AQ, it's an acid. If it doesn't have AQ, it's going to likely be an ionic compound. Yes,
Recap why it matters if it's not oxygen.
because there's a whole, I haven't gotten to that yet. So I'm not recapping, I haven't gotten to that yet. Hydrogen is a nonmetal, but it is a ionic element. It has a positive charge. So if I told you to name HCl and it was a gas, the fact that hydrogen is an ion and chlorine is an ion, you would use the ionic naming rules. There are no prefixes when it comes to the ionic naming rules, so that would just be hydrogen chloride. But if you had HCl with aqueous after it, that tells you that it is an acid. And because I can see with my own two eyes that there is no oxygen in HCl, you will use the binary acid naming rules. You start with hydro, you then use the root of the second word, chlor, you then end it with ic, and then you add the second word acid. So Francis was asking me about recapping oxygen. I haven't got to that yet. And we're going to get to that now. Naming oxyacids. An oxyacid has several indicators. One, what do all acids begin with? It begins with hydrogen. Two, what must be in parentheses following this to let you know acid, acid, acid? It's got to be aqueous. If you don't recall from yesterday what aqueous means, it means that it dissolves in water. That's what aqueous stands for. It just dissolves in water. Here's number three. Why do you think we call it an oxyacid? What else should it include? It includes oxygen. Okay. So, how to name them? All right, I'm going to give you guys an example. Best teacher's experience. What is the first element that you see here? That's hydrogen. Very good. So that's 1/2. Let me be clear about this. Hydrogen represents 1/2 of this entire acid. So what is the rest of it? What is left? What have I not underlined? NO3. And what is NO3? Nitrate. Very good. That is the other half. So, is there oxygen in this acid? Yes, there is. So we have to go by the oxyacid naming rules. And here are the rules. Number one, identify the ion that contains oxygen. In this case, in this particular example, what is the ion that contains nitrogen, or excuse me, what is the ion that contains oxygen here? Nitrate is correct. Very good. Number two, does the ion have the prefix hypo or per in it? Now, there are some polyatomic ions that have hypo or per. Does nitrate have either? No, it doesn't. So move on. You don't need to worry about it. We'll do examples where you do. Step 3. What does the ion end with? Here's your choices. Does it end with ITE or ATE? What does nitrate end with? It ends with ATE. Okay, step 4. If ending is ITE, you replace with OUS. If ending is ATE, you replace with IC. So what does nitrate end with? ITE or ATE? So what will you replace it with? ATE is going to be changed to what? IC. And finally, step 5. Second word is going to be acid. So that's a mouthful here. Take it one step at a time. You cannot eat an elephant in one bite. You got to take it step by step. So we have 5 minutes. Let's go ahead and try to name this guy. Identify the ion that contains nitrogen. Or excuse me, I keep saying that. Contains oxygen. Well, that's going to be nitrate. Got it. NO3. Does the ion have the prefix hypo or per? No, it doesn't. What does the ion end with? ITE or ATE? It ends with ATE. Nitrate. If it ends with ITE, replace it with OUS. If it ends in ATE, replace it with IC. So instead of saying nitrate, we're going to say nitric. And then the final part, the second word is just acid. So what would the name of HNO3 be? Nitric acid. That's because it's an oxyacid, not a binary acid. You only say hydro with binary acids. You do not begin with hydro on oxy acids. Max and JD, you get this 100%.
Yeah.
Sure.
No, I didn't.
Okay. So we have 4 minutes. Let's do just a few examples. What if I gave you, let's try this. HClO3. Now, I know I did not tell you to memorize ClO3, so I'm going to help you out with this. What you have to do first is you just have to look at this. What is 1/2 of this entire acid? Hydrogen, that's right. What is the other half then? ClO3. Now you're like, well, Mr. Thorson, you didn't tell us we had to memorize this. How am I supposed to know what the charge is? There's a way to find out. How many hydrogens are attached to it? What is the charge of just one hydrogen? So what must the charge of the chlorate be? That's right. This is called chlorate. You did not have to memorize that one, so I'm happy to help you. Now, okay, step 1, identify the ion. It is called chlorate. Does it begin with hypo or per? It does not. Step 3, what letters does it end with? ATE. What do you end ATE with? IC. And so what is the final step? What is the second word? Acid. This is called chloric acid. Let's see. Here's one that is found in soda. And when I was in high school, it's just kind of getting a little nerdy. I remember I was a camp counselor for a YMCA counselor for the 5th graders. And I said, you guys want to see something cool? It's like, ooh, what? If you put an earthworm in a bottle of soda, it'll dissolve in a matter of hours because soda has this acid. It even says it on the ingredients label. This is stuff you're putting your teeth in. Obviously, you have hydrogen. What's the rest of it? What's PO4? You did have to memorize this one. Phosphates. Very good. What is the charge of a phosphate, by the way? Good. Now, you see oxygen in there. What would the name of this acid be? Phosphoric acid. One more. This, because that's just, remember I said sulfur and phosphorus or phosphate are the two. You wouldn't say phosphate.
So it's the same with the polyatomic.
No, that would be hydrophosphoric. You would have hydro. It's the same ending. It's the same ending, but you know it's not the same as phosphorus because if it was P, it would be phosphoric acid. This is just phosphorus. All right, tomorrow we're going to do more practice with naming, and then we're going to have to move on.